We made it on time.
We'll use that.
You guys ran.
No, we took a leisurely stroll. So for a quiet day.
It's
Oh, is that right?
it's somehow noticeable. Once
So
the dew
far.
point is above 55,
Like
I start
curly
noticing
cowboys. Dating over, yeah.
I just don't know, like, I don't think we're gonna get anything.
Otherwise,
Granted, that's what I thought about last night.
Fremont, Nebraska.
What are you thinking? Oh, I looked at the HRRR. I don't know if I was looking at the right thing, but it was kind of.
So the SBC keeps moving so we're no longer in the slate.
Okay, that's
now
fine.
we're completely.
Yeah, and then I'll start with that.
Oh, really? Did it just update?
Yeah.
Now we're going Okay, we can get started. I hope everyone's having a good Friday.
Oh.
No place there.
Yeah. This is Weather Watch for April 18th. I'll let this loop at least one more time. We've had active weather, especially today. You'll see a couple systems that I'll point out specifically, but I'll point them out as they loop. Here first was the snowstorm we were talking about last week. Produced some snow over the Northeast. There was another storm that came down from Canada, impacted Montana and the Dakotas. We did not get snow from this, thankfully. Two nice developments right back to back. And then you can sort of see the makings of our system. This was the beginning stage. There was snow over the Rockies. And then here's the thunderstorms that impacted us, most notably this morning. And we'll take a look at those in depth as we go forward. I'll let this loop one more time. But you can see it's been active, especially over the Atlantic. Here's one cyclone. This one slowly moves to the east. Here's the next one on its heels. Develops into almost the same looking cyclone, slightly north. You can see with a nice cloud band. And then we add another cyclone in Canada, and eventually this cyclone that impacting us will make its way over the east coast here. So could we go to April 12th?
Just 1 second, one
yeah,
last
sorry,
thing.
sorry.
For the first time ever, I think, I've been able to watch this. Watch here. Oceanic eddies, because there's a clear spot that
Yeah,
lasts
that's
long
right.
enough. You can really see them evolve. Like, once this thing goes by, there's
Oh, yeah.
really some interesting structure. And then if you keep your eye on that spot, you can see them evolve.
Great point. Yeah, this is the Gulf Stream right here. Warmer water to colder water. You can see it from space.
Yeah, that's pretty cool. Usually
There
there's
was
too
a-
much cloud.
That's right. I even saw a loop in the eddy. Let's see. I think it's after this. You see the clouds moving over. They look like the water temperatures. Let's see. Yeah, here you can kind of see a swirl. You're fine. So there you can see little eddies.
Yeah, that's really
As
cool.
the Gulf Stream moves and evolves
And they-
very slowly compared to the atmosphere,
Yeah.
as you can see. But yeah, little notches. That's the Gulf Stream right there.
I was
Yeah,
just
very
going to
cool.
point out these little Cookie Monster bites that you see are not issues with the satellite. That's on purpose. It's called bright light avoidance. Like this time of year when you're right near the solstice or the equinox, the sun is in line and they don't want the sun shining into and wrecking the detectors, so they block that section out. So anyways, when you see that around this time of year, that's what's going on.
Very cool.
It's over Greenland. That's interesting.
Well, the sun is off the side there, and
Yeah.
those are areas where they're avoiding.
Interesting.
So, all right, I'm done.
Yeah, no worries. Can we go to April 12th at 7 UTC? So I'll step
I'm
through slowly here. So if you were out Weather Watch last week or tuned in, there was potential for snow over the Northeast, and it did snow. There were places in central Mass and then southern New Hampshire got up to 8 inches of snow from this event. There was one main cloud band. You can kind of see a cyclone trying to develop, low clouds behind the cold front, which is not really coherent, and some structure to the warm front here. One band of snow, and then if we go forward just a couple clicks, you'll see there is more convective elements. If we just click forward a couple times, you'll see just developing in the wake of the main cold front passage. So up to 8 inches of snow from this dilapidated cyclone here. that's all I want to point about for there. If we could go to the next day at 9 UTC, so you'll see this storm moves off over the east coast, becomes much more developed, much stronger storm. Here's another snowstorm in Montana and the Dakotas, up to 4 inches of snow in Montana from this, and trace amounts in North Dakota. But if we click forward just a couple times here, you'll see a cyclonic rotation to the clouds there. So very small scale, but it still produced decent weather. We were getting we were in between rain to our north and just a warm front moving to our north. This was Sunday, so it was cloudy. Not a bad day in the 60s, but we didn't get any rain from this. This is all just upper level clouds over us. Here's that cyclonic swirl you can see most notably there.
Yeah, Patrick, I was just gonna comment, last Weather Watch, we were talking about looking at Saturday and Sunday, and I was
That's
sort
right.
of speculating that Sunday would be the cooler of the 2 days, despite what the MOS was saying, the model output statistics for the
Yeah.
GFS, and it turned out to be
Exactly
exactly
right
correct.
on. Yeah.
Yeah, I mean, it was still cooler, both days were cooler than MOS, but it's kind of interesting, even with the clouds, we still managed to get much warmer, so warmer convections were
Did
planned.
Moss beat Morgan?
Yeah.
Is that at first?
It's close to a first.
It's rare.
Top
I'm
five
sure.
anyways.
Okay, if we could go to April 14th at 12 UTC. And I'm going to be honest, this is the first time I ever read what's up here. So it's instructions on how to use this website. Can we shift click?
Has it always been there?
It has, yeah. If we shift click there, you can create loops, which is why I'm doing this.
Short loops.
Oh,
We
I
did
see.
this during the pandemic, John. I worked with Tom, can't think of his name right now.
Whitaker?
There's some- Yes, thank you. Who developed this software, and he put this functionality in there that you
That's
can crop
great,
it.
yeah.
And then if we scroll to around 20 UTC, and then we'll shift click again here. So there we go. We created a loop from 12
Very
UTC to 20 UTC. So pretty cool. I've
It's
never
pretty
done this.
small text, you need your glasses on, but.
But you'll see two nice cyclones back to back right here. 1, 2. And they're almost at the exact same latitude band. So kind of interesting. They have different structures, obviously. One stretches all the way down to the Caribbean. This one is confined to the continent, stretches back towards the South Plains, but nice looking cyclones here. And they were too far north to impact us, but we got the clouds and cold advection. This was Monday when it was cloudy and cold. So that's interesting that happened, and we can create a loop with them here. And then if you want to get out of it, you alt-click on the blue circle. And there we go. Now we're back to the loop.
Wow.
We don't have to reset anything.
Very
so
choice.
pretty cool.
And if you save the MP4, it'll do just that little section that
Oh,
you
will?
did.
Okay.
Yeah.
Perfect.
Yep.
So yeah, that's your fun fact for Friday is
Yeah.
you can create loops in here. Could we go to April 16th now?
So make MP4 will make an MP4 loop of what you're looking at. If you click Save All, it should save all of the individual images. So if you want images rather than a loop,
Rather
you
than
can do it
loop.
that way
Okay.
too.
Sounds good.
Where are we going?
April 16th, 10 UTC about. You'll see we had that cold air advection Monday and Tuesday. It was cold. Produced lake effect snow in Lake Huron and then in Lake Erie in Ontario. This is all lake effect snow. Up to 4 inches in New York and Pennsylvania. I'm not sure about Canada, but so nice lake effect snow in the wake of this cyclone. That was the one that was over the continent a couple days earlier. You can see the warm frontal cloud band and then the cold frontal band nicely reflected there. And then in the cold air advection over warm waters, you get the lake effect snow, which is still going on in April here. And then if we go to, this is the last time I'm going to point out, if we could go to April 17th, and we'll create another loop here. April 17th at 9 UTC, please. And if we just shift click, we'll just look at the end of this whole evolution here, and we can play it, please. So you'll see, here's a look at, there was severe weather over Omaha, Nebraska area, which we'll take a look at. And then that severe weather moved over southern Iowa, and then you can see at the end here, if we could slow it down a little bit, please. You'll see at the end, our storms are also developing, so Towards late day yesterday, here's the development of the severe weather over Omaha, moved into southern Iowa, and then here's our severe weather right behind it. There were 2 bands of nice thunderstorms that moved through. We had hail in both of them. You can see that, especially at the beginning. And very high, very cold cloud tops, high clouds, indicative of thunderstorms. You can see the only other place you see those high clouds are in the tropics, so that's how strong these storms were over Omaha and then over us right here. So we'll take a look at more in depth of those 2 events here. And that gets us to this morning, since it's the end of loop here. But that was our severe weather and a recap for the week here. So could we go to the look at the hail damage, please, first? The very end here. So just north of Omaha, this is what the hail did to a house.
Wow.
Reports of softball-sized hail. These are probably falling at 50, 60 mile an hour at least. So it just wrecked the siding. There are pictures. I think if we click here, maybe there's the 3 pictures here. Yeah. So completely taking off siding. Probably this window is not completely in its place right now. You'll see if we go back one. This is the air conditioning, so that's probably ruined, at least in some effect. Then if we go to the very last picture here, there's only 3 of them.
Oh.
Somebody's car.
Yeah.
And so this was the hail damage from last night for softball-sized hail, and we actually had softball-sized hail in Wisconsin at the same time, or close to softball-sized hail. So I can only imagine there's someplace just to our south that has damage like this. Unfortunately, and you can see this is well after the storm has passed, sunny skies, it's not raining, and you still see these huge hailstones all over the place. So imagine trying to get to work and that's your car.
You can't do it.
That's unfortunate. And this is just north, Fremont is just north of Omaha, so a lot of people live there. It's not like this is just in the middle of rural Nebraska, so interesting. And then there was also a couple tornadoes produced by these same storms that we don't have pictures of, but so very intense damage from these thunderstorms. These moved to our south in southern Iowa, and then we kind of got the same dynamics, but just different storms here. And we'll take a look at those. So could we go to weather.gov, please? If it's up.
I heard it, I don't see it.
That'll work, actually, if we go to SPC. And if we go to storm reports. And so I'll first go back a day. We'll look at the storm reports here. So there were the storms. This is relatively where Omaha is. You can see there are tornadoes reported with this significant hail. Everywhere you see a triangle, a black square. I remember my shapes. Black square, that's significant hail. And so if we scroll down to the hail reports, you'll see these are the tornado reports. If we keep going to the hail, and everywhere it's bolded and italicized. This is 3-inch hail. Wow. We keep going. A ton of 2-inch plus hail right here. There's even 4-inch hail in Nebraska. So imagine that falling at 60 miles an hour at your car. It's going to wreck it. At your head, yeah. There's another 3+ inch hail, another 4-inch hail. So significant hail, many locations in this region. And if we scroll up to the map again, in all of Nebraska, this is like the most populated region of the state. So a nice bullseye for where you don't want all this weather happening. This hail was not the stuff that hit it this morning. We have to go ahead a day, and you'll see a nice bullseye over us for the hail. Everywhere green is hail. There is significant hail. If we scroll down here, these are all in Wisconsin so far.
2.5 everything.
2.5, 2 and 3/4 of hail. So this was only 20 miles to our south. This could have easily hit us, but we got 1 inch or pea-sized hail. So we'll see these come in throughout the day, but this is what moved through and probably woke people up. If you were up before 8:30, if you woke up after 8:30, it was sunny and nice, and you had no idea this happened. So, and then if we look at the loop here that Pete created, we'll see we had like spotty, just rain showers move through. There's even like a undular bore that moves through, and then we get this significant hail, 1 line and 2 line there. And Edgerton is somewhere in this circle, I don't know exactly, but if we focus on, it was that first line that moved through here, where there, you see
Yeah,
these
look at that.
wider colors. This is DBZ 75 plus DBZs. This was where we saw the close to 3-inch hail reports. You can see it just moved. Here's Madison, so it's just to our south that this moved through. So cool, but it of course creates damage, which is not cool. Could we now go to, we'll look at the 2 soundings, please. Could we go to pivotal weather? So I want to compare the soundings from the Omaha storms and our storms because they both produce hail roughly the same size. One of them produced tornado, one of them did not. So if we could go to models, we'll go back in time here. And if we could go to the model, and we'll do the HER here. And if we could go back in time, we'll go to 18Z yesterday. And then if we scroll down, let's see, to the reflectivity with precip type, and jump ahead to hour 4 or 5, actually. So this was a model depiction from the HER model of the storms. Here's the storms beginning to develop over Omaha. You'll see first synoptically, there's a low pressure system or a cyclone sitting over the eastern Rockies. You have not significant baroclinicity as represented by the temperature, but there is significantly strong southwesterly flow into where you have flow that's largely parallel to the thickness line. So you have warm air advection, fairly weak, but it's there, and to no advection. So you have a bullseye of differential warm air advection right over the region you have storms developing. So synoptically, you are going to get some uplift for these storms to develop here. If we click just ahead of these storms.
Yeah, and arguably in the boundary layer, you have frictional convergence along the cold
Absolutely.
front too, so there's going to be extra frontogenesis there.
Absolutely, right in the cold front,
Yeah.
that's just slightly to the north of where these storms are developing, yes. So first, it was a warm day. It got into the mid-80s in eastern Nebraska. You'll see, so this is roughly the time that it was happening. First, we had southerly flow near the surface, shifting to more westerly as you go up. Significantly strong, so there's a nice area of veering or warm air advection throughout much of the column. That's reflected in the photograph here, where if you were to plot the wind at the surface, that would be this 0, and then going up to 1 kilometer, 2 kilometer, 3 kilometer. In the lowest levels, you'll see there's nice shear, both in speed. You see the speed changes as represented by the rings, and then also the direction. So you have southerly flow into westerly flow just from the lowest 3 kilometers. That's a lot of shear. That's good for thunderstorm to develop. If we look at the sounding, the profile here, if you were to lift a parcel from the surface, you see the representative parcel track is this dashed line. You essentially have free lift. The cape is pretty significant, and there's really no inhibition. Nowhere this parcel would be colder than the environment. And so if you have something like a lifting cold front or a warm front that's going to create lift at the surface, lift these parcels up, you are creating free motion as you just go from the surface up into the atmosphere. And you need a portion of it to be below freezing to create this hail. So you have really strong lift. You have a lot of this profile is below freezing, and so there's where you can produce significant hail because you have both synoptic and mesoscale lift going on here as represented by this atmospheric profile. You can see at the surface it's mostly dry adiabatic, so it follows the dry adiabat, and it's pretty moist, and so you're going to lift parcels essentially from the surface all the way up to where they stop near the stratosphere. And we had deep convection, which makes total sense. As represented by these numbers here, you can see there was really strong cape, no sin, and so anywhere you could create that lift, get a thunderstorm generation, you're just going to freely lift that parcel. you know, possible hazard type, marginal tornado, okay, that's pretty good. It did produce a tornado, so that's good. But you can see analogies, they take these soundings, compare them to significant events, and you'll see both hail and supercell tornadoes were pointed out. So pretty good in terms of model world, where this did produce significant hail and a tornado. So this was the Omaha sounding here. Yeah.
Question,
Yeah.
the fact that there is no inhibition, what would the consequences have been if there were even just a subtle amount of that? Would it build up more cape?
That's a good question. Probably not, because at this time you were cooling at the surface. So I wonder if there's competing effects between, this is sun's going down.
This is 18.
This is 18Z plus 5.
Oh, plus
so
5,
It's,
okay,
yeah, so it's
okay.
near sunset. So if you're cooling the surface, you're
Sure.
gonna move the profile to the left, but yeah, maybe throughout the day, if you were to build up some sin, you could produce significant lift, specifically focused on a.
Okay, I was thinking it was 18Z, so that.
Yeah,
that
yeah,
makes a
yeah,
big difference.
no worries. Yeah.
Thanks.
So it is a little curious why only one storm, or one region produced, you know, there were a couple embedded supercells. There weren't just a big, from the model world, if we click out of the sounding, there weren't just a overhaul or a lot of development. This is pretty accurate to what happened. It was just this localized storm that moved from Omaha to southern Iowa, and that seemed like the only game in town was this storm, this supercell here. That is a little curious, I would admit. Yeah.
Were you capped further to the east?
At the same time.
Yeah, they're around the same time. Let's go right there.
It's a good question. Yeah, so you were a little bit, where this dashed line would be the parcel, and so in this region, the parcel is colder than the environment. So you would need another forcing mechanism, some lift, further lift to get the parcel to lift past this layer here. So maybe that's why the tornadoes are more significant in Iowa, because of that little cap, but still a little curious why there wouldn't be a lot of thunderstorms developing in this region here. Because there's significant moisture and it's warm still in that whole region here. Now if we go to our storm that happened, so if we go to the model run, we'll go forward to 9Z, and just 1 hour ahead, you'll see the model did pretty good with our storms developing. There were 2 lines, one here and one here. If we click near Madison, oh wait, actually I want to point out this notch tail first. So we had that cyclone over eastern Rockies. It weakened, but we still have significant warmer advection out ahead of that, where the storms are developing. And it largely goes from, we have warmer advection to little to no advection. So we're still in a region of differential warmer advection right over our region here, right ahead of where these storms are developing. If we click on a sounding right near the 6, this is approximately Madison. You'll see a much different profile. We have capping inversion near the surface. This is overnight into the morning hours, so the surface, which was in the 60s, cooled off to the 50s. You'll see any parcel that is lifted from the surface is likely not going to make it, not going to freely lift. Our parcels were largely elevated, so they, anything 700 and above now is where you have your more of that cape profile. I think this is actually, this is a different sounding than I was looking at. But you still have any parcel that's going to lift is going to be in the upper levels, elevated than at the surface here. We have strong shear, same strong shear. It's just we did not have the really warm temperatures at the surface and not as much moisture as in Omaha. But these profiles still produced roughly the same amount of hail, and the same size of hail, which is interesting. And I think if we actually, let's click out and just go one step forward to 2 or 11Z. I wonder if we click ahead of the storms developing there, this is going to be more representative. Yeah, so this is a little more representative. We now have more cape in the upper levels, just nothing near the surface. And so you lift a parcel from 700, much of that profile is going to be below freezing. that's likely a reason why we had a lot of really small hail, specifically over us, is because much of the profile is below freezing, so you're more readily able to freeze and produce hail, just not as large as what was in Opa. and
No wind
Western
either.
Iowa.
There was no wind, it was notable today.
Exactly.
That was an interesting characteristic. You couldn't mix the air down, unless you had
Exactly,
trees that grow to like 980 millibars maybe.
That would be, yeah, that'd be interesting.
Then you could have them ripped off the top.
Yeah, something we pointed out earlier was
Oh, yeah,
that
thank you.
the lapse rate at the bottom is conditionally unstable, so if you have moisture all the way up, you're gonna be absolutely unstable. Like, you're gonna have unstable lapse rates all the way through the profile.
Exactly right, yeah. I'll point that out here. Good, thank you for that. So this actually plots or calculates the lapse rates here, and you'll see at the surface, from surface to 3 kilometers, 2.6 Celsius per kilometer. That's in this sort of capping inversion. But if you go just 3 to 6 kilometers, so 700 and above, suddenly you're conditionally unstable. And this holds true 850 to 500 and 700 to 500. So you need that elevated convection, elevated parcels to lift. Once they do, they're conditionally unstable.
Yeah.
We have moisture, specifically in the upper levels, and so that's likely we had storms developing, 700 and above. This is where our hail formation was, not anything near the surface from this representation here. That's my best guess, and Potion's best guess from this morning here. Okay, that was a recap. Let's go to the current satellite.
Oh, just one other thing.
Oh, yeah.
Pete, that goes straight up to the tab there, just in terms of rainfall. You mentioned they're further up to the tabs, the T to the right, right, one more.
This one?
Well, yeah. So
Oh,
this
yeah.
is, from my backyard, just the sort of 2 pulses of rain that came in this morning, which is kind of neat.
Oh, yeah, that's
Yeah,
very cool.
up to an inch of rain. I was driving, I know you're not supposed to drive during severe weather, but I was.
Turn around, don't turn around.
Yeah, I did. I did actually encounter some streets that were flooded, so, yeah, really intense precipitation and 2 quick bursts. So you didn't really get you had strong precipitation, you didn't really get a recovery enough. The sun was still down, so there wasn't a lot of evaporation, and then you got another round of heavy rain, and so this was likely the second push for our flooding.
Yeah, the airport was just a little over half an inch.
Yeah,
I
that's
haven't
right.
been to other sites yet, but.
And you're a little far south, right? Yeah, so it seemed like further south you go, more rain, heavier hail. Yeah, very interesting. Okay, let's go to our current satellite, and then I'll just look at 500 and then be done here. Oh yeah, we can look at the radar for sure. I'll use, yeah, perfect. So you'll see here's the current satellite. We have a nice clear day over the eastern United States. There is some moisture flow from the Gulf, these low-level clouds, the spotty cumulus coming up from the Gulf, and that was likely some of the moisture we got for our storms here. The storms that hit us, you can see them moving over Lake Michigan into the state of Michigan and then into southern Ontario there. Largely just a mess of clouds in the Central Plains tied to a really deep trough. You can see it in the clouds. Nice high-level clouds moving from the Pacific up over the terrain in Mexico and then over the Central Plains here. So this trough was likely one of the mechanisms why we had a cyclonic development, and then that moved over us, helped produce the storms, probably now into Canada, although it's hard to see any cyclonic rotation here. One thing I pointed out last week, I'll point out again, you can see Western Canada is largely snow-free. There's not that speckled land surface like in Central Canada and then Eastern Canada, you can see. So as this keeps happening, we keep warming. Our cold air usually comes from Canada, so this is good if we want to warm up because we need to keep melting the snow in Canada for it to get warm up there so it can stay warm over us here.
I think that the snow cover over central and eastern Canada persisting is what's keeping us cool.
Absolutely.
Because
Yeah.
we keep getting these ridges that form and we get the easterly and northeasterly flow.
Absolutely, yeah. So we need to erode this snow cover over Manitoba primarily, or some parts of Ontario there. That's what's keeping us cool, exactly right.
Some interesting march of the daytime cumulus along the Florida coast and then the Carolina coast too.
Oh yeah, Yeah, you can see it
And
as you get flow from the Gulf, or from the Atlantic over warmer land than the water, and so it heats up, and you can see Lake Okeechobee.
Yeah.
Because the water is still cooler relative to the land, you don't get cumulus over the lake.
Yeah, some of them try to blow over the lake, but they die. You
Exactly,
can see
yeah.
even that, it's
Yeah,
amazing.
exactly. Because it's still pretty cool.
Yeah.
Yeah.
But why is it coming in? It's not just the sun angle, right? Or the sun's.
It must, I bet you it's like an advection, a slight advection off the warm, moist ocean, but I don't know why it would be.
Is it super warm?
You can see it in the Carolinas.
It's
Yeah,
pretty
it's right.
warm,
Yeah.
it's pretty warm there.
Yeah. There might also be land convergence
Yeah,
slightly.
I don't know, it's just,
Frictional convergence, yeah.
It's very
good point.
interesting.
There's- over
Even
Carolina as
over
well.
Cuba, you see a little bit of it too.
yeah.
Yeah, very interesting. Can we take a look at the radar, please? So let's see, here's our storms. They've since weakened as a move over us just by the reflectivity. It seems like there is a slight mesoscale vortex. You can see it rotating slightly cyclonically as it moves across Michigan and into Canada there. But largely these seem like they're done. I don't know if they have any warnings on them right now, but we were the beneficiaries of the really intense storms this morning at least. And then where we saw that mess of clouds, there are some, the radar's picking up on precipitation. I know this is snow in along Denver, so they had the classic, it was 86 degrees and then the next day it's snowing, and you wake up and it's 30 degrees. Probably won't last since it's April, but nice plain snowstorm there. But aside from the central United States, both coasts seem pretty good in terms of radar here. No real precipitation from that advection over Florida and then the Carolinas there. And then if we just look at 500, and that'll be the last thing I show, just to look at that trough, please. So we'll go to the super peats and look at the trough ridge pattern here. So we saw a nice deep trough in the clouds. You can see that reflected in the upper level chart. Positively tilted, if you were to draw your trough axis. So it's no surprise that our cyclone was weakening as it moved because of this positive tilt here, but it is still significantly cold in this really cold air in the trough axis and warmer out ahead. And so we were right in that nice region where we're still warm, but we're having this influence of the upper level trough, creating that cyclone and producing our storms over us. Here was our spring. It seems like we might get colder. I'm not sure if that is 100% true as this trough moves through. But then nice wavy flow. We have a trough, ridge, trough, slight ridge, another trough. So this is represented in the week-long loop and also the satellite where we had a lot of different events go through because of this really wavy flow, as you can see here.
It's got a pretty big gap in observations out there. South
Yeah,
Dakota,
no kidding.
Wyoming, Colorado,
Yeah, look
Utah,
at
there's
this.
none.
Yeah.
Green Bay's missing.
And that's exactly where you would want observations right now,
Right.
because that's where the weather's happening, so, yeah. Yeah, I know people were saying Omaha should have released a balloon yesterday, but they can't, so. And that's there were tornadoes and hail, and so that would be really good to measure that, so we can predict it further, but it's not happening anymore, so. Yeah, the world we live in. Does anyone want to see anything else? My hand up.
Thanks, Mac.
Yeah, thank you, Patrick. Let's keep this up. And, yeah, so the last point that Patrick made about the lack of observations, the soundings that we have here, I mean, certainly, I'm sure, and also the observation you made that the big event for hail was right near Omaha. Big population, probably a lot of property that was damaged, and having, observations that people could have, maybe those observations could have helped them make better planning. Don't know, but I'm sure insurance companies are gonna, may regret not having additional observations to warn their consumers, their customers that severe weather was expected. But I know the forecasts were for convection, so at least you had that. The trough that's been pointed out here at 500 hectopascal was really maybe almost two trough features.
Yeah.
One from sort of Salt Lake City to just south of Reno, and then we have this other feature that's in the southwestern part of the United States. So these are going to play a big role in our weather when we get into Sunday afternoon into early Monday. As we'll see, the orientation of this trough is going to take on a more negative tilt as it propagates toward the east and ultimately northeast over us, triggering a cyclogenesis event, as well as a period of some rain and maybe a little bit of snow in the northwestern part of our state by the end of the weekend. The other thing I just wanted to take a quick look at was we saw those clouds coming in over Florida. You know, at 500 hectopascal, we see the northerly winds or northwesterly winds. Let's just go down to 850 for a second, Pete. Let's take a quick look at that. It's not really strongly easterly. Maybe we'll go down one more level if we can. Is it more northeasterly? So the winds are backing like that's cold
Yeah.
convection. So maybe that's it. It's the advection of this colder
Yeah,
air
along-
over a warming surface, and then you're getting the convection
And the
bubbling up.
low-level easterlies are making it as moist as you can hope for.
Right.
Yeah.
Yeah.
That's a good combination.
So that's really good there. Okay, so one of the things that's happened this morning, we had the convection go by, the trailing convection, but we still have a lot of baroclinicity to our west and to our southwest. We have a fairly prominent looking upper trough that's going to be arriving in this vicinity of baroclinicity, and that's at least the raw elements for perhaps a cyclogenesis event, and that's what we're going to see when we look at the forecast. So let's go over to pivotal, please. Pete. Yeah, PPP, pivotal, please, Pete. All right. Get rid of that. And we will, let's actually, I think the representation in this, in the run, let's go to the 3 kilometer map. Okay, actually, we'll come back to that. Let's go to the GFS first. And we'll look at this, the evolution of the upper trough in a couple of different ways. One, if we could scroll down a bit and to what they call dynamics, I'm not sure why. Look at the 500 hectopascal vorticity, and we're going to just step through this over time. All right, at this level, that trough doesn't show up as well, but the one that was to the southwest shows up pretty nicely. This is in the 500 millibar relative vorticity that we see there. And let's just step through and look at the evolution of the vorticity field with this trough over time as it rounds the base of the trough. Again, this is a very messy vorticity pattern, but you can see the minimum in geopotential just over southwestern Utah. We keep moving forward. Same time, gets a little bit more rounded, consolidating, and notice the tilt is slowly beginning to change. We had an orientation more like this at the beginning, now it's moved to the south east. Let's keep going with it. Now at the base of the trough, nice, well-rounded trough, but again, downstream of it, it's only a faint hint of a ridge, so the wavelength here is still fairly broad. You're not going to expect much in terms of upper tropospheric divergence at this point, but it's beginning to look a bit more favorable. Let's keep moving forward. Okay. Some weird effects perhaps with convection, flow over topography, but by this time, maybe zero tilt, if not even slightly negative. But again, the way this downstream ridge is not particularly prominent just yet. And we're now at Sunday, just early Sunday morning, and I'm guessing, and we'll see, that this speckled appearance we see in vorticity might be from convective towers that have developed. But again, this is a nice, sharp upper trough, and maybe the beginnings of a ridge forming more prominently closer downstream. So a favorable area for ascent over Oklahoma by the time we get into Sunday morning 12Z. Over us at this time, we saw a ridge axis that's just beginning to pass by, so clouds are probably going to begin to come in on Sunday by mid-morning. Let's keep going. So by the ridge, and then we have this nice pattern. Again, it's not the greatest example of this, but we have, I would imagine at this level, if we look further up, we would see a nice pattern of divergence and ascent that's developed now over parts of Missouri. A couple more clicks as we go into, stop right there. Really nice upper trough, and you might expect just very close into this, over parts of central and eastern Iowa, there's probably going to be a really good push of ascent ahead of this trough and the rain perhaps beginning to move in. But we're not just going to focus on the upper trough itself. We know we had some varicomicity that was lingering around during this time period. So we're going to look at also the interaction of varicomicity with this upper trough, but also just the lower tropospheric flow with that varicomicity. And we'll see we'll see frontogenesis just to our south that's also going to contribute to some of the precipitation. But not a bad upper trough once it gets developed. But the other feature to notice doesn't seem particularly important at this point for us, but this other little vorticity feature behind it, I think is going to linger once this weather system moves out. And so we're going to have kind of unsettled weather into early next week.
That thing in Nebraska is really interesting, because I was watching it as you're going through these pieces, the times, I mean, there's a thin strip of vorticity that connects it to the upper feature, and it's just one of those little swirlies that develops along it. So it's probably barotropic, and the temperatures must be adjusting underneath it as time goes on, because it didn't start out as a barotropic feature at all.
That's really interesting. I didn't look at that feature directly, but yeah, that's something to look at. So if we go back to let's just loop this first of all, then we're going to go down to 850 hectopascal. Just loop.
Forecast loop?
Yeah, forecast loop, but we're only going to look at the first 72 hours to get us to Monday morning. Instead of, we can let it just run. Okay. Things begin to consolidate. We have this strip of vorticity.
See that little thing right there?
Right here, yeah. And that becomes our.
It's just a little swirly.
Trough after that, and
Then
then
it
it moves
gets-
over us as we get onto Tuesday. Let's stop that for a moment. Let's go back to Sunday morning and look at another depiction of this. So we'll get to 48 hours. As the upper trough begins to come out of the southwest. Maybe just click on 48. We don't need the loop right now. Okay.
Every time I move the mouse over.
Yeah, just
I don't like that.
click on 48. Just click on 48 over there, please. And we'll go to another depiction of this. Let's look at it on the dynamical tropopause. Where is it? Right here. Looks quite a mess, but here's that upper trough. So colder potential temperatures along the dynamic tropopause indicates a sort of depressed, not unhappy, but just lower tropopause located right over the Texas Panhandle near Amarillo. And this feature again is going to be one that this is in this depiction right here. It's actually a nice, very short, small-scale feature, but it doesn't have sort of a nice deep connection to the colder potential temperatures further to the north. So this is not going to really have much chance to amplify, but it can get deformed over time as it moves toward the northeast. But we would expect if we were to do a cross section through this, which as I'm talking about it, maybe we do want to do that. But this would go to tropical tidbits. Maybe if we went dual cross section on them, say just roughly from the southwestern corner of New Mexico up to St. Louis, I guess. We'll do that in tropical tidbits at 48 hours. By the way, that tropical cyclone that was out over Australia did get to Category 3 strength, and then it actually made a sharp turn to the east and made landfall in northeastern Australia.
Queensland?
Don't know the.
I think it is, but I don't know.
We can go to CONUS. And 48 hours. And from here to St. Louis. And we can look at, let's go look at the PV. This I did not do. Oh, yeah, that's actually a pretty nice upper trough. I think the dynamical tropopause gets all the way down to almost 500 hectopascal, kind of averaging out, smoothing it out here. You can see the nice couplet of winds you expect for that cross section. The reduced stratification beneath the upper PV anomaly, right? Or this considering this anomalous relative to its surroundings. So colder beneath, warmer above. You can see the isotropes dipping down above this and being sucked up, if you will, underneath it. So increased stratification here, decreased beneath as well as above. So that's not a bad upper trough. Particularly, and it's very small scale too.
Yeah.
Okay. And this, we'll go back to the, to pivotal, please. And let's just advance this forward through, for the next 24 hours. So 48, oops, I'm sorry, not step by step. 48. We can do every 6 hours, we don't have to go through each time period. Nice things about this particular map are to the extent that the flow is adiabatic and frictionless. So frictionless is probably okay at this level, but adiabatic, there's some questions away, particularly away from the upper trough, but we could just use the winds to affect these features to the, just follow how the winds are affecting it. See how this is going to move along. Let's go ahead another 6 hours. And the trough gets eaten away, so that's also another indication that diabatic processes are eroding this tropopause undulation. We'll get to 66 hours. And kind of just fizzes out. But there we are, just to our west as this passes by us. And here's the other feature that we saw over Nebraska. It doesn't really show up as well here at this level, but we can see this extension down here.
It's an excursion of the tropics all the way up to Hudson Bay, James Bay. I mean, this is the first time maybe this year this is
Very
like
low
this.
PV, or not very low PV air, but warmth along the dynamical tropopause all the way up to Hudson Bay is, that's something that's, we begin to see this time of year as we move toward the warmer season. I guess Greg Tripoli would be talking about the tropical jet now.
Yeah. Well, and and Libby would be talking about the disappearance of the polar jet, because this is probably one of the features that actually does that. It just kind of eradicates it, and all you have left is the subtropical jet. So maybe it's events like this that are part of that transition.
Indeed. So let's look at 850 now. We'll get out of this. Go back to some temperatures. What's the temperature? Yep, there we go. And let's go back to 48 hours. We'll just take a look at the evolution of the cyclone. So a nice, vigorous 850 millibar cyclone to the west of the thermal trough, which we know this is where the upper trough was. We saw 500 millibars along the dynamical tropopause. Nice warm advection to the north. We can see these winds as we move northward toward where the barochronicity begins to get concentrated. These winds are kind of fading out, so there's a strip of frontogenesis that extends from just south of us all the way into just west of Lincoln, Nebraska. Good old Lincoln. Let's step ahead.
Yeah, how's
6
everybody
hours.
at home? They didn't have any trouble with the hail?
No problem.
All right.
That was all in Omaha. It's a long story, folks. We can tell you about that. Still, frontogenesis persisting. This barochronicity beginning to increase. This cyclone looks fairly decent as it begins to wind up. It doesn't really deepen significantly. We'll see that in the surface maps. But again, when we look at the precipitation, the surface precipitation map, we're going to see, again, band of precipitation here, but also some precipitation in this developing thermal ridge that's right here as well. All right, let's go ahead another 6 hours, 60 hours, there we are. And so one of the things that, we're not going to have time to look at multiple forecasts, but the track of 850 millibar cyclone as well as that at the surface, take your pick on which one you want to track. The models have it either moving into southwestern Wisconsin or staying to our west, and that's going to play a big role in whether or not we actually break out of the precipitation Sunday evening. After a period of precipitation Sunday mid-afternoon into early evening, will we break out into a warm sector, or will we stay in sort of a rainy pattern through the evening? So that's one thing we're going to watch. In this forecast, it looks like we're might be just beginning to make the warm front lifting just toward north. Let's go ahead to 66 hours. And by then, if we do get into a warm sector, we're going to be getting back in, things are going to begin to cool off again. And again, the northwestern part of this, does go below zero at 850, so maybe some frozen precipitation well along northwest at that point.
April 20.
And so there is our cyclone. So let's look at the surface map and see how things have evolved. We'll start off at 48 hours. Please. Okay, so here's our cyclone at 1,006 hectopascal over the Oklahoma Panhandle. For us, again, we have this big anticyclone over parts of Ontario and the Great Lakes, and that's going to keep us in a cool, in this case, east-southeasterly flow. And we'll step forward in time, but it's dry early Sunday morning. By the time we get to Sunday 18Z, the rain is just on our doorstep to the south. And again, the day looks like it's going to be getting wet as we move beyond that time period. Convective precipitation, in terms of the splotchy precipitation amounts we're seeing here, out ahead of this developing cold front. Let's go ahead another 6 hours, please, Pete.
Oh, boy.
And again, rain, and it's going to be just miserable by mid-afternoon, or late afternoon, I guess, with an increasing gradient over us, pressure gradient over us. The geostrophic wind is certainly going to be getting more intense. So kind of a wet afternoon with the precipitation. And we go ahead just 3 hours with the squall line is to the south. We can get into convective precipitation as this begins to move forward. So in this, even though we looked at 850 cyclone had us further to the east, one of the things that's, or had us look like we're gonna get into the warm sector, I'm kind of wondering if we're gonna see really much of a break in precipitation
Yeah, I
given
don't
this
think so.
evolution. If
That's
we were to go,
intense.
if we were to go to, so, Sunday evening could, a round of some maybe impressive thunderstorms. If we could take a moment, Pete, and just look at ECWF, if it's available. At this time, maybe it should be. Look at its track. This is a different story. It looks like the rain is actually just beginning by the time we look at this. Let's
Well,
go to
this is
48
zero
hours.
Z though. This is
Oh,
not-
0Z. Oh, no, this is 12Z.
I know, but it's
Okay,
zero
zero
Z
Z,
in
right.
the forecast, so we
So
have
if
to
we
go
go
to
back-
66-hour forecast to get
Yeah.
something comparable. And even that'd be off by time, right?
These are the same map times.
I think we were looking at 03Z for the forecast time on that prior one.
Okay, yeah, okay, so we can go ahead, but, yeah, so here's the rain by the time we get to 60, but if we go back a couple clicks, Pete, just getting started and go back another
Yeah.
one, by right afternoon, this is a little bit slower,
Yeah,
just
it's
for the
later,
arrival
yeah, that's right.
precipitation. And so things are a little bit slow, but you're right, that was at 63. If we go to 66, there's that convective line to the south, that kind of matches up, and we're still in the rain, according to this forecast. I just want to do one other model run, the icon, and we'll just go through the same times again. This has us clearly in the rain as well. So this is 12Z, rain to the south, we expect that. Nothing new here. Mirrors kind of a GFS with the rain
Yeah.
arriving, and then this is a weird combination, but the precipitation staying around us into the Monday morning. Let's go back to the GFS and we'll just continue this out. So icon also has a little bit more intense. So we get into the dry slot of this cyclone by the time we get to midnight on Monday, and we'll go ahead to Monday morning. And there's the snow, fall to the northwest, and we're just sort of cool, but with this broad cyclonic circulation around us, we're not going to get particularly sunny, I don't think,
Yeah.
during the day. And we'll go ahead to 78 hours in the forecast, and maybe even some remnant light precipitation over us as this begins to move out. So
Could we go to 160
yeah, sure.
or thereabouts?
162.
Yeah.
Yeah.
Oh, I guess maybe 12 hours earlier than this, or?
Okay, 150, all right.
Yeah, okay, thanks.
What are you looking for?
Some events on Thursday.
Okay.
May be potentially impacted by the nothingness of that event. But look at it, looks just broadly unsettled,
Right.
ugly.
So it's still relatively warm.
Yeah, oh yeah, it's not gonna be cold.
Yeah. And just looking ahead broadly, I mean, outside of the forecast, let's go up here, and the CPC outlooks for the extended range. As we get into the week after, after next weather watch, we should be expecting sort of above normal temperatures. The 6 to 10 day outlook, if we go to the 8 to 14 days, that persist as well. So that's actually
So
not too bad.
the last 2 weeks of the term will be finally kind of warm.
Yeah, that's how it's looking, at least in this thing. Precipitation wise, maybe a slight chance of being above normal, both this period and I think the following period as well. So,
Yeah, right.
but short term, we have another round of convection later this afternoon, possibly. Rain event on Sunday evening into early Monday, and then kind of showery Monday with a lot of clouds and cooler. That's about it. I guess we'll get up to near 70 today, 60s tomorrow, and then Sunday in the 50s with rain. Thank you. Thanks, Pete. Thanks, Patrick.
Thanks, Michael, thank you, Chief.